All right. This is states of matter. And we're going to start with gas, what a gas is. And the first thing we're going to talk about is the atmosphere. Because the atmosphere is all around us. It's made of gas. It's very heavy. Wouldn't you say that? Couldn't you have said that, Laura, that it's heavy? It's very heavy, right? It's very, very heavy. When you go to the moon, you've seen astronauts on the moon. They've talked about Mars. What do you have to wear if you go to the moon or to Mars? Can you just wear a heavy coat? Would that help? What do you have to wear? You have to wear special suits. Why? Because of what? Is there a lot of pressure there?
Yes.
There's a lot of pressure on the moon. Sure about that, Z-Man? Really? Okay. Anybody think there's a lot of air pressure on the moon? Raise your hand if you think there's a lot of air pressure on the moon. Raise your hand if you don't think there's a lot of air pressure on the moon. Look around there, Z-Man. Yeah. Does the moon have an atmosphere? No, it doesn't have an atmosphere.
Okay, then why does your head explode when you remove the thing?
Because there's... Okay. Let's worry about that in a minute. We'll worry about the exploding head in a minute, okay? Can we work up to that? Okay. The first thing I want to explain to you is what a Pascal is. One Pascal. We measure pressure in terms of pascals. But does anybody really know what a Pascal is? Does anybody have a clue what it is? Not really, okay? So let's turn some lights on here. So let's talk about what a Pascal is, okay? Let's talk about what a Pascal is. All right. Does anybody know what pressure is from your middle school years? Does anybody been in MYP? Anybody know what pressure is? Kennedy. Like? Are you going to sound like an 8th grader? You're a senior, ready to graduate, ready to go to the great universities on planet Earth, and you're using the word like? It's like, dude, you know what I'm saying? Yes, Kennedy, I apologize.
A simple definition, I guess, would be like putting a force on something.
Putting a force on something. Okay, that's good. Okay, I have no problem with that. So what would, yes, T? An amount of force on a specific area. Very good, excellent. Amount of force on a particular area. And that's really that's the classic definition of pressure. Pressure is force over area. Okay, that's what force is. That's what pressure is. Pressure is force over area. Does anybody know what force is? Anybody there? Anybody here? What a force is? If I said to you 1 Newton, would that mean anything to you? How about if I said the Americans in the group, 100 pounds, would that mean something to you? Anybody weigh 100 pounds in here? Laura, you weigh about 118? Too much?
Pounds?
Yeah.
No.
110?
No.
Less?
Yes.
108?
Less.
100?
No.
102?
Less.
101?
94.
She weighed less than 100 pounds. Wow. Okay, so Laura is a perfect example. Could you stand up over there? If I'm embarrassing you, please say so. Okay. All right, Laura is 94 pounds. Okay, so she's about, divide 94 by 2.2. Divide 94 by 2.2. What do you got? What is it?
42.7.
So she's 43 kilos. Okay? Is that all right? Do you get a picture? How many kilos are you? Do you have any idea?
Kilos?
Yeah. About 100 kilos?
92.
92 kilos. All right, he's 92 kilos. Right there. Okay? I'm 100 kilos. T. Anybody know their mass or their weight in kilos, which is not really a weight? Anybody? How much are you? You're 70? You're 70 kilos. All right, stand up, please. He is 70 kilos. Okay, he is 70 kilos. How much are you?
I'm 69 kilos.
69 kilos. Anybody else? Yes. 40 kilos. 40 kilos. Aiden. 54 kilos. Excellent. So if, Aiden, would you do me a favor? Would you stand up on the desk? Use that stool and stand up on the desk. Would you please? Would you please stand up on the desk? Use a stool. Stand up on the desk. Okay, now. Now, how much are you? You're what? All right, be careful. It's soft ceiling. 50. He's 54 kilos. I am almost, God, I'm twice. I'm 100 kilos. So, that right there is 54 kilos. Okay, thank you. Hey, you can sit down. All right, so that gives you a little bit of an idea, a little bit of a reference point so far. Okay, yes? Okay, well, force, we have to find out what a force is, right?
Yeah.
Now, this is going to be a little bit weird, so you're going to have to say, okay, we'll allow you to do that, all right? When I go like this, you say, okay, we'll allow you to do that. Let's practice, all right? You ready? 1, 2, 3.
Okay. Allow you to do that.
Okay, well, we'll do one more time. Okay, we'll allow you to do that.
Okay, we'll allow you to do that.
All right, so that's going to be a little bit weird because this is not a physics class, but you have to know what pressure is, okay? All right, now. Force, according to Newton's second law, and you may have had this in middle school, is mass times acceleration. Mass times acceleration. Let me make sure that goes on. All right, let's move this a little bit like that. Okay, mass times acceleration. That's what Newton's law is. Okay, now, if I drop this, right, it's going to accelerate. We're going to round this off, okay? Acceleration due to gravity equals what? Does anybody know what it equals, approximately? Yes. 9.8 meters per second
Squared.
squared. 9.8 meters per second squared. Are you okay with that? Yes or no? Well, what we say is, I'm going to erase all this. What we say is, we just simply say this. We say 10 meters per second squared. And what does that mean, meters per second squared? Where does that come from? That means, yes, Aiden.
Is it meters a second a second?
All right, meters per second per second. Does anybody know what that means? If I drop something, it's going to accelerate, meaning it's going to have a change in speed, right? Because acceleration is velocity over time. Yes, T.
Yeah,
What were you going to say?
the acceleration was speed times
Divided by.
by
Divided by time. In other words, as I drop this, it's going to accelerate 10 meters per second every second. So at the end of 1 second, how fast is it going? 10 meters per second, right? It's easy, right? At the end of 2 seconds, how fast is it going? 2 meters, how fast? 20 meters per second, right? At the end of 3 seconds, Ginny, how fast is it going? 30 meters per second, right? Right? It's going to increase its velocity 10 meters per second every second. So at the end of 10 seconds, how fast is the object falling? 100 meters per second, correct? You okay with that? Okay. So that means that 10 meters per second every second. Isn't that true? Isn't that what it means?
Yeah.
10 meters per second divided by seconds, right? Yes? So isn't that the same thing as 10 meters per second divided by second? Isn't it? Yes or no? Isn't that what it means? Isn't it? Okay. Doesn't that equal, remember, if you divide, the same thing as multiplying by its reciprocal. Do you remember that in math? Many years ago. Times 1 over seconds, right? Which equals that. Which equals this. Right? Do you see where you get that squared thing from? You see that? So it's simply 10 meters per second every second according to the equation, right? So then 10 meters per second divided by a second, which is the same thing as saying 10 meters per second divided by a second, which is the same thing as saying 10 meters per second times 1 over seconds, which is the same thing as saying this, which is the same thing as saying this. Correct? Yes? Okay. So, when you sit there, you feel your body? You feel your body? You're sitting there. You feel your butt, right? And you feel a weight, don't you? Don't you feel a weight? I'm standing on my feet, and I can feel the weight of my body coming down to my feet, right? Now, if you're hang your feet from the stool. Don't put them on the rung. So all of the weight, all of your weight is on your butt, right? And you can feel that weight, can't you? Yes or no? Well, believe it or not, we say, now are you ready to say, okay, we'll allow you
To do that.
to do that, okay. What you are is you're accelerating. I know you're not moving, but you're accelerating. Your acceleration is 10 meters per second squared. So what we say is, I'm going to erase this, is that all right? We say that the equation is what? What's the equation? The equation is F equals ma, which equals, for me, I'm twice what Aiden is. I'm 100 kilos.
Okay, we'll allow you to do that.
Okay, we'll allow you to do that. Okay. In other words, the force is going to be your mass times the acceleration due to gravity. You see that? If I take that chair away out from you, what are you going to do?
Forward.
You're going to fall to the floor. What happens if there's no floor? You're just going to keep falling, right? You're going to be in free fall, aren't you? Because there's no opposing force, is there? See, that's what you're missing. You're missing Newton's third law, which says, if I push with 5 newtons, how much does the board push back? 5 newtons. You get it? Or if I push with 5 units, the board pushes back with 5 units, correct? Yes or no? If you push down with 100 kilos, I'm going to push up with 100 kilos, but we don't say kilos because that's mass.
Mister, if you keep on falling and you don't stop, will you be on fire?
If you fall in the atmosphere, yes, but we're not going to talk about that right now. Yes, Aiden.
But if you keep pushing the board and you don't apply enough pressure, it would eventually break. So
If I could do that, yes, if I pushed with more force than the board is pushing back, I will accelerate that way. But we're not going to worry about that right now because that's physics. But yes, that's correct. If I push the wall stronger than the wall pushes back, then I break through the wall, of course. But if I push back and there's no movement, if I push and the wall pushes back and there's no movement, the wall pushes only as much as I'm pushing. You get it? So if you're going to push back this, See the unit labels? Kilogram meters per second squared. Kilograms times meters divided by second squared. If you push down, I'm pushing down, right? Let's say I'm standing on a piece of paper. The paper breaks. I push down with greater force than the paper pushes up, I fall, right? But if I push the floor, what's the chair doing? The chair is doing what? It's pushing back up the same amount that you're pushing down. Don't you feel that? Don't you feel that? You don't really notice it unless I say to you, do you feel that? Now all of a sudden you feel that because you take it for granted, don't you? Yes? You see this? Kilogram meters per second squared. We don't go around saying that the force that I'm pressing down is 1,000 kilogram meters per second squared. What do we call, anybody following this? What do we call kilogram meters per second squared? What do we call that? What do we call that? One kilogram meters per second squared equals one what? Yes, T. One what?
Newton.
1 Newton. That's what the Newton is. Named after Fig Newton. I'm kidding. Named after Isaac Newton. Okay? Yes. Yeah, go ahead. All right, so I weigh, my weight is 1,000 newtons. And that's how you say it. F sub W, that means weight, as opposed to pushing force or something like that. My weight is 1,000 newtons. Do you understand where newtons comes from? You get that now? Aiden, you don't understand? Okay, all right. Do you understand that my weight equals mass, which is 100 kilograms times 10 meters per second squared? Do you understand that? You do? Okay, good. So do you understand that my weight is 1,000 kilogram meters per second squared? Do you understand that? Kilogram meters per second squared.
So that's what, okay, yeah, I was wondering about the 1,000.
That's a Newton. See? 1 Newton is 1 kilogram meter per second squared. That's all it is. If it sounds simple, how many people say, well, that's a little too simple? That's all it is. That's all it is. It's nothing more. All right, now, we're getting there. This is big. We're getting there. We're getting there. Now, let's say I have a box. Okay, I am a terrible drawer. Okay, let's say we have this box. Okay, that's a box. Okay, let's say that box is 1 meter by 1 meter, this way, 1 meter. Are you okay with that? It's 1 cubic meter. So, 1 meter. 1 meter deep, right? Yes? 1 meter deep, deep like this, 1 meter wide, whatever. Yes? Dimension 1, dimension 2, dimension 3. Do you understand? So I'm in this box. It's this tall, correct? 1 meter tall, it's 1 meter wide, and it's 1 meter deep, okay? And it's filled with water. Okay? It's filled with water. Okay? I can put in here 1,000 liters of water. That's what I can put in here. 1,000 liters of water. What's the mass of 1 liter? Anybody idea? Anybody have any idea? You know that a liter is 1,000 milliliters? Do you understand that? Anybody ever look at a bottle which is a liter? Do you know that it's 1,000 milliliters? Laura, do you know that? I'm asking you a question. I need a direct answer. You do. Does anybody not know that? It's okay if you don't. I'd just be a little surprised. Okay? You get it? Yeah? Okay. What's the density of water? In chemistry, we say the density of water is what? We say the density of water is 1 gram per milliliter. Yes, T.
Yeah.
I don't know, you had your hand up.
Yeah, density of water is one.
Density of water is 1. That's right. Density of water is 1 gram per milliliter. So if I have 1,000 milliliters, how many grams are in a liter? Alex? You can do this. You're looking at me like I'm crazy. But if I tell you that the density of water is 1, right? Yes? And if I say to you that a liter has 1,000 milliliters, what must I put in the numerator for it to be equal to 1,000 milliliters? How many grams? It's 1,000 milliliters. This says the density of water is 1 gram per milliliter. If there's 1,000 milliliters, how many grams are there? 1,000 grams. So 1,000 grams over 1,000 milliliters. Yes?
But isn't the H2O that we can fit in there is 1,000 liters?
1,000 liters, that's correct.
Yeah, but we calculate if 1 gram equals to 1
Could you hold off on your question? Hold off on your question. I know where you're going. I understand. Hold off on your question. You're confusing liters and grams. Okay? You understand? You're confusing liters and grams. How many kilograms is 1 liter then? 1 kilogram, right? So 1 liter equals 1 kilogram, right? So how many kilograms are in a cubic meter? How many kilograms are in a cubic meter? T. How many kilograms are in a cubic meter? If 1 liter is 1 kilogram, and I can put 1,000 liters in 1 cubic meter, Aiden, how many kilograms are there in 1 cubic meter of water? 1,000 kilograms. What's the weight, FW newtons, of 1 cubic meter of water, therefore? No, that's the mass. What's the weight? We just did this. What's weight? FW. 10,000 newtons. Do you get that? 10,000 newtons. I'm going to erase this. You can go back and look to see what it is when you look at the video. Okay, you all right with that? Yes or no? Okay, good. Now, so 1 cubic meter. 1 cubic meter. 1 cubic meter has a weight of 10,000 newtons. You told me that. Yes? So what's the pressure? What's the pressure of that water per the area 1 square meter? I'm almost finished. You got to hang in there. I'm not doing more than this. This is give me another 10 minutes and I'm done for the period. Finished. What is the pressure per square meter of that box? What's the pressure of that box per square meter? You can do this. Remember, it's force equals, pressure equals force over area. What's the force? What's the force?
10,000.
10,000 newtons, right?
Yeah.
What's the area?
1 square.
No, that's the volume. What's the area? What's the area that's sitting on the floor? It's this by this. What's the area sitting on the floor?
Miles squared.
1 square meter, right? Isn't it? 1 square meter? Isn't that the area? So what's going to be the pressure?
10,000.
The pressure equals 10,000 newtons per meter squared. Correct? Yes or no? I'm asking you a question. You okay with that? Okay. Now, let's say that you were under that box. That box weighs 1 metric ton. 2,200 pounds, 1 metric ton. Is that heavy? Is that heavy? You have to go under that box, Baslin. Are you unhappy with that? Are you unhappy with that? I'm asking you a question. Yes or no? Is that heavy?
Yes.
Okay, well that's what I asked you. Yes or no? Is it heavy? Shout it out. I don't want to. Oh. Anybody who doesn't think it's heavy, raise your hand. All right, so we all agree that it's heavy, right? Okay, good. Now, let's do this. You've got to go under 10 of those. Okay? Is that really heavy?
I will be dead.
What's the pressure? What's the pressure of 10 of these same boxes? 10 boxes. 100,000 what?
100,000 newtons.
100,000 what?
100,000 newtons
Square.
per.
Per meter squared, right? Yes? Yes? Has anybody figured out where I'm going with this? Does anybody know what a Pascal is yet, T? No? What's 1 Pascal? What is it?
Newtons over meter square.
Yes. 1 Pascal equals 1 meter, 1 Newton, sorry. That's the atmosphere. So what is the pressure of the atmosphere in pascals? What is it? 100,000 pascals. That's right. Or Aiden, you were trying to say it before. You weren't quite sure the numbers. You were like, you had memorized the number once many years ago, but you didn't really weren't sure where it came from.
I was talking like hectopascals.
If I divide that by 1,000, it's going to be 100 kilopascals, right? That's air pressure. That's where the Pascal comes from. The Pascal comes from 1 Newton per square meter. You get it? 1 atmosphere is really heavy. It's an amazing it's an amazing pressure. But we're built for it. It's amazing. You wouldn't know, you wouldn't think that. We're so fragile. But we're built to withstand that kind of pressure. Yes?
Is it a direct pressure though? Because if that weight was just lying on top of us, like in bricks or something, wouldn't it crush us?
Pressure won't.
No, it would, yeah, I understand, but then what you're saying is that if you took the same pressure, I don't know the answer to your question, I'd have to think about it, but if you got rid of all the pressure, if you got rid of all the atmosphere and replaced it with brick, I don't think it would be that heavy. We wouldn't feel it because we wouldn't have the pressure. But the problem is that we wouldn't have the pressure inside our bodies too pushing out. I'd have to think about that, but just let me say this. Let me say this. That this is 10 meters. Right? Isn't that 10 meters? 10 meters, isn't that true? 10 meters? Yes? Because I have 10 boxes. Yes? 10 boxes, right? You okay with that? Yes or no? Okay, now, that's of water, right? 10 meters of water, correct? Yes? Now, if I go down 10 meters under the water, that's 1 atmosphere, right? If you take a sub down way, way down below its capacity to endure the pressure, what happens to the sub? It gets crushed. It implodes. Doesn't explode, it implodes. I don't know the answer to your question. That's a little bit more complicated because you also have the pressure inside pushing out of your body, etc. So it's not as easy as that because it's a fluid. It's a fluid. It's not, you can't replace it with bricks.
Yeah, no, but that's not, I'm saying, so 100,000 newtons is that 10,000 kilograms?
No. 100,000 pascals is 100 kilopascals, right? Or 100 kilonewtons per square meter.
What is that in mass?
We're beyond mass. We already multiplied that by acceleration. We're not talking about mass anymore. It's not in mass. You got to go back and look at your notes, Aiden. We'll go over it again. Let's get through this, and then we'll go back and look at it again, okay? All right? Okay? Do you understand that it's not in mass anymore?
Yeah, I know. Don't worry.
I will worry. I can worry. But thank you for letting me know what my options are. But one of those crates, wasn't it 1,000 kilograms? Wasn't it? One of those crates, wasn't it? Yes or no?
Yes.
Okay, so times 10 would be 10,000 kilograms, isn't it?
Yeah, that's wrong.
10,000 kilograms, yes or no?
Yes.
Times 10 would be what?
100,000.
So, but is it kilograms or kilograms?
No. Get rid of kilograms. We're done with kilograms, Aiden. We don't talk about kilograms anymore. We're in newtons. We multiplied kilograms times acceleration due to gravity. We have no more kilograms. Why do you keep going back to kilograms? It's not in kilograms.
I'm just wondering what the weight is on us in kilograms.
It is, the weight on us in kilograms is 100,000 newtons per square meter. In terms of a mass, it's 10,000 kilograms per square meter. That's the mass per area. Is 10,000 kilograms per, is that what you want to know? What's the mass? That tells us nothing. But what it can do is it could give you a little bit of a understanding of what that might mean. 10,000 kilograms, right? 100,000, 10,000 times 10 is 100,000 newtons per meter squared, correct? If you wanted to look at it in terms of a mass to give you a better understanding, it would be 10,000 kilograms
Yeah.
per square meter. Does that help?
Yeah.
Okay. All right. We're done.